Hello and welcome. In this lecture we are going to be actually attaching wheels to our tank rather than just these springs. So the final effect, without any need to apply sideways friction as we've been doing previously, is that if we go ahead and hit play, our tank will land on the ground and it will roll down the hill, but only in the direction that the wheels should be letting it roll down the hill. As you can see here, it's rolling down, even though there is a slope going down in towards its left. It is not rolling down leftwards. Friction is doing its job and it's just rolling off the edge of the cliff like that. So that's what we're going to achieve, and I'll see you in the lecture to make it happen. Okay, so we've got a tank that is sort of suspended on these weird funny blocks, but we would like something better than this ideally. We'd like a tank suspended on wheels, going back to the idea of a sprung wheel where our tank is actually rolling across the ground rather than rubbing across the ground as we've currently got. What we want to do is figure out how that's possible, and the way to do that is by chaining constraints together so that we can get a wheel attached to a spring. Let me talk a little bit more in depth about that. So this is the setup we want, right? We want a spring and a wheel attached to it. At the moment, we've got a cube attached to a spring. And what's unique about a wheel? Well, it's going to roll. So at the moment, we've got our spring, which isn't actually an object. A spring is a constraint between our tank and our wheel. What we want to do is introduce something new into the loop here, an axle. So we're going to have our spring as a constraint between the tank and our axle. And then the axle has its own constraint between the axle and the wheel that allows the wheel to roll freely in the right axis, in the axis of the axle, which is what we want. Okay, and how's this going to look? Well, we're going to have the following chain of constraints. We're going to have the tank, which is going to be a physics body, then a spring constraint between the tank and the axle, and then the axle having its own constraint between the axle and the wheel, and then finally the wheel. So the axle wheel constraint isn't going to be a spring. We're going to set that up differently. It's going to be a constraint of rotation. It's not going to allow certain rotations. It's going to allow certain other rotations. And it's not going to allow movement at all. Whereas the spring, as we know, is allowing movement in that Z direction, but with those linear motors that try and bring it to restitution, to rest. Okay, so that is the idea. That's what I'd like you to do and set up this sprung wheel. Now, I'm going to leave it mostly as a challenge for you to set up that sprung wheel, because I think you've got most of the building blocks. I'm going to give you some hints that should prompt you along in the right direction. So the requirements. So your setup needs to be sprung like before, so it can't just be a rigid wheel attached to the tank. And the wheel needs to wheel freely in the forward and backwards directions, so you're able to, your tank will go very nicely forward, but if you put it on a slope facing sideways, it shouldn't slide down the slope. So essentially we're doing away with that sideways friction force that we've had to put in programmatically, and we're doing it via these physics constraints instead, which will be really great. So here are some hints for you, because this is quite a big challenge just by itself without any hinting. So here are the hints. That all constrained items will need to simulate physics, so none of them are going to be kinematic. They all need to have physics simulation switched on. In order for an item to simulate physics, it does require colliders. So it needs to have a collider on it. That means that if it's a static mesh, it needs to have a mesh so that it has a collider. If it's any other physics object, they're often colliders in themselves, like the cube collider components and things like that. They have colliders in them, so that's great. But it needs a collider in order to simulate physics and in order for you to be able to attach two constraints to it. And then you want your sphere component. So the sphere component is a really good example here because, first of all, it's invisible and it's something that is the right shape for a wheel. Slightly the wrong shape, but you can wheel around on spheres and it will look all right. So I do recommend using sphere components instead of static meshes. I've been using static meshes to visualize, but sphere component might be really helpful. And then you don't want the axle colliding with anything. So I've said you need colliders, but remember that doesn't mean that colliders actually need to collide with the environment. Remember, go back to thinking of how your colliders are set up and make sure they're set up correctly. Make sure you check the log messages if anything isn't working well to see why that might be the case and see if you can fix it for yourself. Now, this is a tough challenge, so don't worry if you don't get to the end result, but just trying is really important. It's going to help solidify the solution if you have to go and watch the solution. Okay, so pause the video and have a go. Okay, welcome back. Let's have a go at this slightly tricky challenge. So first up, I'm going to set up the new axle and its constraint. Those are the new things that we're introducing here. Let's go over to our C++, and I'm going to browse down into the private folder to particularly our sprung wheel CPP. And actually, I'm going to need to go over to the header file first of all, because if I go over to the header file, I need to set up some new properties. So let's go over and add another wheel, like so. And I'm going to change it from being called a wheel to being called an axle. And then I'm going to add another constraint just by copying over the constraint as well. And the constraint I'm going to rename to mass axle. No, sorry, the axle wheel constraint. And what's actually going to happen is we're going to be using our mass wheel constraint for the mass axle constraint. But I'm not going to rename it because otherwise our entire setup of that component is going to go missing. It won't be able to associate it to this. Now, there are some tricks to work around this, but they're a bit in depth. So for now, we're just going to avoid this for now and avoid renaming it. There are some ways that you can rename it by ending it with deprecated and then moving it across, but I will link to those in the resources. Actually, I won't link to it in the resources, but just as an aside, if you want to find out more about it, just go and search through the engine code for _deprecated. And if you go and find everything in the entire solution, find all. And I'm just going to take a look at the example from the paper flipbook component.cpp. You'll find many such examples. You can see that they've implemented a post load function here, and what this does is after loading it checks whether you've got anything in your deprecated property, and then it sets the new property. So what it does is it takes all the details from the old property and moves them across, and then often they will set the deprecated property to null, and then later on in later versions you can remove the deprecated property entirely. Go and have a look in the engine if you want to have an extra challenge of actually trying to do that, but I'm not going to do this right here because we've got enough to worry about. So let's go over to our CPP after that aside, and I am going to set up our axle constraint. So I'm going to do that by first of all copying the wheel setup for the axle and rename axle where appropriate, like so. And then I'm going to do the same thing for our constraint itself. So it's going to be the wheel axle constraint. What did I call it? Axle wheel constraint. And I'm going to rename the F name, and I'm going to set up its attachment. Now, what attachment do we want here? I personally want to have the wheel attached to the axle, so I only have to position the axle in the world, and they will be in the same place. Why do I want them in the same place? Because remember, we need to rotate around the center of the wheel and around the center of the axle, so I think this is going to be the easiest way. And you'll see what I mean once I've set up the attachment. So I'm going to do an axle wheel constraint that's going to be with a setup attachment to the axle. And in fact, what I'm going to do is I'm going to set up attachment so the wheel is also attached to the said axle. And we'll see what that ends up looking like. I think I've got that all right. We've still got the same root component, and everything else is set up with attachment to the axle after the axle has been attached to the mass wheel constraint. The only things we've got to do here is actually change how we set our constraints. So I'm going to make a copy of this set constraint in our setup constraint, and we're going to have to set up our axle wheel constraint, which is obviously going to be between the axle and the wheel, whereas now the mass wheel constraint is not between the mass and the wheel, it's between the body root and the axle instead. So we are going to go ahead and build with that too, and go over to the engine and open up our sprung wheel BP, see what we have ended up with. So sure enough, the wheel hasn't been childed properly. Did I set it up properly? Yeah, it looks like it, so it's probably just cached. Let's make sure we reboot the engine. Sure enough, now it looks correct. We've got the axle and everything underneath it. Now I'm just going to set it up so the axle is the one with the offset rather than the wheel. So let's copy the Z offset from the wheel, set it down to 0, go over to the axle and set it Z offset there. So now we've got the wheel is centered on the axle, with its axle wheel constraint at the center there as well. Now, there is going to be a slight issue here if I want to set up physics. So in order to simulate physics on our axle, you'll notice as a static mesh, I cannot simulate physics without having set some sort of mesh. So I'd have to select a mesh, then I can simulate physics. But we don't want it to actually have a mesh. That's kind of annoying. So let's use some USphere components instead. I'm going to go over to the code and simply replace our UStatic mesh components with USphere components instead in both places, because both of them will work very nicely as USphere components. Now, don't worry, changing the type here actually transfers across most of the same properties, because apart from the static mesh obviously, but we don't want the static mesh anymore, so that should all be fine. Let's go ahead and build. Okay, and let's have a look at what we've got. There we go. So we've got this invisible collider, which is only visible when we've got collision visibility switched on, and they both have a collider. So we do have to think about this, because we don't actually want the axle to collide with the wheel when they're actually in the same location. So let's select the axle, go down to our collision setup, and instead of block all dynamic, I'm going to go for overlap all, so everything is allowed to overlap with the axle. But furthermore, I'm going to go and make this then custom, because what I want to make sure is that when we have this collision enabled property, you see it's set to query only, which means it won't be used for physics, and then we'll get a complaint in the logs. So what we need to do is switch this over to collision enabled query and physics, so we can go ahead and compile that. Now the axle isn't going to collide with anything, but it does have physics collision set up for all intents and purposes. So let's go over to our level for testing, our spring test bed, and have a go with the tank, see what's going to happen. Go ahead and hit play. It's dropping down, which is satisfactory, and it passes right through the ground. Now, the reason for this is, you should have guessed it, we've got some physics instability, so it's probably that our masses aren't quite right. You go and look at the axle, in fact, the mass that it defaults to, well, in fact, it's not even simulating physics, so that's not particularly helpful. Let's set it up to simulate physics and just check that we still get a weird issue. Falls to the ground, but yep, just kind of falls right through the ground. Doesn't work very well. So if we go to our axle and enable the mass, you will see that its default mass here is 100, which isn't very useful because that is quite a lot smaller than our tank mass. So let's set that to 1,000 and see if that improves the situation. Go ahead and hit play. Yep, there we go. It's now resting on its haunches. And what I want to show you is that this will indeed be rotating. So let's go and give some slant to this floor. Go ahead and hit play. And now my tank goes and rolls down the hill. You can test for yourself and see that previously it wouldn't have rolled down the hill with the setup of suspension that we actually had. And because I've got collision visibility enabled, remember that you can do that by hitting the key underneath your escape key and then hitting show and then space collision, tab to complete, and that will show all your collisions in the world. And you can see that those spheres, those wheel spheres, are actually rotating around and allowing our tank to roll down the slope. So we want to constrain this properly now. This is the final step. So let's go to our axle wheel constraint, which was actually just set up as default for now, and have a look. We've got our linear limits completely locked, which is what we want, but our angular limits are not. So you can play around with this to find which one you want enabled, but what we actually want to be free is the swing to motion, and you can see the direction this is going to go in with X forward, and you can see that it's allowing it to rotate around the Y axis, which is what we want for this wheel. And you could play around and see, you could even trial it out and see you can make your tank go sideways and things like that, which is quite fun. So let's go ahead and hit play now. It's going to land on its side and boom, just sticks in place right there on this edge. So we don't have to apply any sideways friction or anything. It is applying that itself through the physics engine. And let me just show you that it will indeed roll freely now if I tilt the plane to go forwards and I go ahead and hit play. You can see that it is indeed rolling down the plane. If we look above, we can see that it is moving in line with the checkerboard pattern. So it is going only down this plane, but not sideways slipping down it at all. So I think that has pretty much implemented our sprung wheel for us. Obviously, it's not complete yet because we have no control over how this tank moves. But if we go over to the battleground and hit play, you can see that it's working in there too. Our tank just goes and rolls on down the hill, and that is looking pretty cool. We're going to have to tweak things around, of course, and make it work a lot better. For example, we're now flying over from the force of those impacts. We're going to have to make the impact a little bit less strong. Lots of tweaking to do, but we've got the basic building block in place. So a big pat on the back for managing to achieve that, and I'll see you in the next lecture.